Welcome to EDU World Space.
Problem 3.96. In this problem, we have to find equivalent force at point C and equivalent moment at the same point while the wooden stick is applying 175 Newton force on the door. Now, this door is hinged about point C, so this door can rotate about point C. So this wooden stick is preventing its rotational motion. So this will apply a force, let's say in the direction A to B. So first of all, we will write the P force in its vector form, and for that we need the coordinate of point A and point B. So if we write the coordinate of point A, so it will be, since in x direction it is at minus 100 mm, so it will be, if we write it in meter, so minus 0.1, and it is in xz plane, so its y coordinate will be 0 and its z coordinate is 594 mm, so 0.594 meter. Now talking about the coordinates of point B, since point B is again in the negative x direction but at a distance of 67 mm, so it will be minus 0.067. Its y coordinate will be 990 mm, so 0.99, and its z coordinate, since it is in xy plane, so its z coordinate is going to be 0. Now talking about the coordinate of point C, so it will be in x direction, it is at minus 750 mm, so minus 0.75. Its y coordinate is 1850, so it will be 1.85, and its z coordinate will be 0 since it is in xy plane. Now talking about the force that is acting along the wooden stick AB, so reaction or the equivalent force at point C will be same the force that is acting along the stick AB, since only one force is present in the system, and we can write this force should be, since its magnitude is given as 175 Newton, so it will be 175 lambda AB, where lambda AB is the unit vector along the wooden stick AB, and it can be written as 175 AB vector divided by mod of AB vector. Now coordinates of point A and point B is already known, so we can solve this. So if we write the AB vector, it comes out to be 175 0.033 I cap, and point plus 0.99 j cap, and minus 0.594 k cap divided by its magnitude, and magnitude is under root of 0.033 whole square plus 0.99 whole square plus minus 0.594 whole square. So if we solve this, it comes out to be 5 I cap plus 150 j cap minus 90 k cap. All the units are in Newton, since this is the expression for force. Now talking about the equivalent moment at point C, for that we can see here that a position vector will be this, that will be position vector of point B with respect to point C. So moment about point C can be calculated by using position vector of point B with respect to C cross multiplied by force that is acting at point along the line AB, and we have already calculated the force acting along the line AB, and since RC was the equals to EAB, so we can write, now we need to calculate the position vector of B with respect to C. Now the coordinates of B and C is already known, so we can solve this, and the position vector comes out to be 0.683 I cap minus 0.86 j cap, and the k cap both have the same value, so there will be no k cap component. This will be cross multiplied by the force that is written here, and that will be 5 I cap plus 150 j cap minus 90 k cap. We can solve this by using determinant method. So it will be I cap, j cap, k cap. Now coefficient of I cap is 0.683, coefficient of j cap is minus 0.86, k cap coefficient is 0, and in the force vector this is 5, this is plus 150, and this is minus 90. So now we can expand this expression along I cap, j cap and k cap. If we expand along I cap, so it comes out to be 0.683 multiplied by 150 minus 5 multiplied by minus 0.86. So this was the coefficient of I cap. Now talking about the coefficient of j cap, it will be 0.683 multiplied by minus 90 minus the second term will be 5 multiplied by 0. Not for the k cap coefficient, it will be 0.683 multiplied by 150 minus 5 multiplied by minus 0.86. So we can get these values by using calculator, and it comes out to be 77.4 Newton meter I cap plus 61.5 Newton meter j cap plus 106.8 Newton meter k cap. So this is the final answer of this problem, that the equivalent moment at point C will be this expression, and equivalent moment and equivalent force at point C we have already calculated here.